Have you ever put some thought into how sustainable you made a new standard? There is a great tool for checking it, giving you guidelines on how to make sure you can sustain your changes. Hello, I'm Tom. Welcome to my channel where we talk about continuous improvement in an industrial setting. And in this video, we'll be talking about a tool to check how stable and therefore how sustainable a new standard is, or actually any standard. You can even use it to check current standards and see which ones might need some attention. And it is the 5 questions for 0 defects. There is a set of questions, and they're right on the board and behind me. And there is also an example for each of those 5 questions in a different setting. So in this video, we'll be talking about the machine questions as an example, but there are also questions for man, so training and how are we checking the skills of our people, method, so basically the work standard, and material, so how do we check the material. And they all work in the same basic way, and they're a great way to test when you are doing problem solving, so you have to update a standard, or improvement, so you create new standards, or simply in your quality management, how good is the standard? Not the content of the standard, but how stable is what we ask our processes to do. By the way, if you would like to use my 6-step problem solving template, please check the download link in the description below, because I've got it for you for free, and it also includes exactly these questions with the examples for each of those 4 categories. So that's a very nice piece of free stuff for you. And now let's get into the meat of what we're doing. When we have a machine standard, we will take as the example, but any standard, we check 5 things, and these 5 are: how well is the standard defined? How easy is it to follow that standard, to implement it? How easy is it to meet the standard? How can we detect if anything goes wrong? And if something goes wrong, how easy is it to restore the process to the standard? I usually use a 1 to 5 point scale, with a 0 even being an option, but a 1 to 5 point scale. And as a guideline, I'll give you what is 1 point, what is 3 points, and what is the full 5 points. So, definition of a machine standard: 1 point is the set points are determined. You somewhere have a document, or maybe it's in the machine somewhere, where you can look up the set points. So at least we know what they should be. Then a level 3, so a mid-level, would be there is quite an easy, preferably visual, but quite an easy way to check the standard. So we have some device or some way described how to check if the standard is correct. And the level 5 would be you can just go to the machine, and without too much training, you can immediately see if the standard is correct. The second question is: how easy is it to get the setting right? So to really put the setting into the machine. Or for material, how easy is it to check if it is up to specs? But for a machine, it means, well, is it hard or easy to actually put the settings into the machine? For instance, during a product shift or a startup, or at any time that it's needed. And level 1 is, well, it's actually pretty hard to set the machine correctly. It will probably require some experience, training, and a keen eye on how to work with this machine. On a level 3, we say, well, it's basically easy, bit of training, and everyone that we train on this machine can definitely do it. So yes, you have to know what you're doing, but this is pretty doable. But it is still something you have to do. Level 5 is the setting is virtually automatic. For instance, when I pick the program for the product that I'll be running next, the machine automatically sets all its set points by itself. That is a very stable, ease to follow the standard. The third question is, and how much does it actually change? So if we are looking to a machine, well, we might set the temperature to be at a specific norm, but to what extent will it keep this temperature during our production run? Or might it at some point, drop off a bit where we have to correct? A level 1 would be here, well, basically during a production run, you already have to check this setting, because we know from experience that in a matter of a couple of hours, this setting may already start to move, to shift a bit. A level 3, for ease of meeting a machine standard, would be, well, yeah, we know that it shifts from time to time. it's more, after a big product change or after a weekly cleaning, you have to check it. So basically, no need to check it during production. If you checked it before you started the production run, that's okay. And a world-class level 5, how stable is it? It basically never changes. You set it, it is there. Now the fourth question is about, if there is a deviation, how difficult is it to spot it? So hopefully there are no deviations, but in practice we will still be checking. And here we try to estimate how quickly you will find the deviation. So when a setting deviates, can we see it? And a level 1 would be only if you are really looking for it, or you cannot really see the setting deviate, you only see it with the product really going out of bounds. A level 3 would be, well, we have already frequent checks in place where a shift in settings would be noted, but it is with some frequency, and you might still be looking at the results of this setting, but at least we know we will not be spending a whole shift with a wrong setting. And level 5 here would be, yes, there is an inline control that quite frequently will check the setting, preferably the setting itself, and alert the operator when something goes wrong. Now, and then the fifth question is, when we see that there is a deviation, how hard is it to restore the deviation? And here a level 1 would be, well, to restore this deviation, you have to be either highly skilled, so only really the operator of this line or experienced people, maybe the mechanical staff, can reset the machine in a correct way once it's running off its setting, or maybe a little bit less training, but you will have to stop the line completely, and this will take a serious downtime to reset it. You can imagine that many production lines, you cannot adjust all of the settings while operating, so you might have to spend half an hour or so cleaning, or even more when you're in certain industries, cleaning out the line, then resetting, starting up again. So if it is difficult or expensive to do the recalibration, the resetting, that is a level 1, maybe even 0 if you just have to completely finish the batch. Now level 3 would be, yes, this is quite doable, especially once you are trained to work with the line, you know how to set it initially, you also know how to reset it, and you can basically do it during production. It's not too much of a hassle. And a level 5 here would be, well, there is a continuous feedback loop. So we know that we detect it, and then the machine automatically adjusts itself, or it is very easy for the operator to reset it and it doesn't stop production at all. The machine can readjust and recalibrate its settings in such a way that everything simply continues. Now, how would you use this? So as soon as you do a change of a standard, and as I said, it's often with problem solving or with improvement of your process, or you have a new process also, and you change, update, or completely invent a standard, check, besides how accurate your standard is, how easy is it to understand, set, how stable will it be in production, and if it's not completely stable, at least how good are we in restoring or finding and restoring any deviations. Because a brilliant standard that is difficult to set and almost impossible to check and correct, that will not give you the stable results that the setting itself might promise. Another way to use this, and this is actually quite common to do with critical control points, if you are in food, pharma type of industry where you are working with a hazard analysis and you identified which points of your production process are really critical for product safety, so food safety, or making sure that the exact correct ingredients are in your pharmaceuticals, then these are really the settings where you want to go and check, even if there's not a problem right now, how stable, how well are the standards by themselves. And that by itself might be a good reason to say, hey, we've identified a number of standards where the setting is correct, or the check for the material is correct, but they are so difficult to perform that we cannot really ensure that any operator on the line will be able to do all of these settings and checks correctly. So let's make sure that we improve parts of this standard to make it easier to understand, easier to set and check and correct, because in that way you can ensure a sustainable, stable production. So make sure that this standard will be followed in practice. Very strong tool. Now I hope you found this tool useful. If you liked it, don't forget to hit that like button. Also subscribe to the channel if you haven't done so already. And don't forget, this is part of my problem-solving 6-step template. There is a free download in the description below. I hope you enjoy it as well. For now, I wish you the best of success and stability with your standards. And as always, don't forget to enjoy your continuous improvement journey.